8th grade, lesson 10, practice problems, adding and subtracting real numbers taken to the next level. Now we've practiced a couple lessons before adding real numbers and subtracting real numbers in which we learn the strategies of same sign sum and different subtract. Now we're going to take that to the next level and apply it to both fractions and decimals and all sorts of different ways in which you would want to use this skill when it comes to solving more complex algebraic expressions. First thing that you're going to keep in mind as we go through our practice problems and your assignment for today is the idea that when you're adding subtracting real numbers and you know your two strategies for same sign sum, different subtract, you can break a problem down into two separate parts. You can put all the addition parts together, because same sign sum, and do that together. And you can put all the negative parts together, same sign sum, and you're adding the entire time. The only time that you would need to subtract then is if there's one of the other in the problem. Let's take a look at our example and we'll try to apply that separation of addition problems together and subtraction problems together, or addition like positive signs together and negative signs together, and then combine those at the very end. If you look at practice problem letter A, you have 4 ninths plus 2 ninths minus 5 ninths. Now in this example, there's nothing to rearrange in the problem and keep the sign because our two positive values are listed right here. So we would go ahead and attack those first. 4 ninths plus 2 ninths. We know that when we have fractions, we need to have a common denominator. In this case, we have that common denominator, so we don't need to change anything by multiplying both the numerator and denominator. So this is good. 4 ninths plus 2 ninths, we would add the two numerators. 4 plus 2 is going to give me 6. My denominator stays the same, and then I would have minus 5 ninths. 6 minus 5 equals 1 ninth. Okay? If this order was changed around and that negative was in the middle, I could rearrange it by keeping the same sign with each of those terms and then put it so that the positive values are together and the negative values are together, and then at the end you come to do that final operation where you're solving the system completely. If you look at letter B specifically says, what is 16.21 minus 21.54 plus 12.74? Now here's how I drew this up in the initial problem. If you're reading it from left to right, you're going to notice that it goes from positive to negative to positive. In this case, you'd want to put these things and put them together. So your positive values are going to be 16.21 and 12.72. I could 16.21 and 12.72, add those two values together. 1 plus 2 is 3. 2 plus 7 is 9, 6 plus 2 is 8, and 1 plus 1 is 2. You get 28.93, and then subtract my negative value as the separate portion. I would subtract 21.54 because that's the negative value or the subtraction portion of our problem. And then I do my subtraction this way. 3 and 4 can't do, so I'm going to turn this into an 8 and borrow. 13 and 4 is 9. 8 and 5 is 3. 8 minus 1 is 7. 2 minus 2 is 0. And I get 7.39 as a positive value. Now, that's initially what they're teaching you in example 1, to separate it into positive parts and negative parts. Here I'm going to show you a second way to solve the problem. We'll see if we get the same answer. I'm going to do it as if I was reading it from left to right, just like the problem says. 16.21 minus 21.54. 16.21 is positive, negative 21.54 minus 21.54 makes that a subtraction problem. If I look at the signs, one's positive, one's negative, different subtract. So I wrote it as a subtraction problem, but those values have to be remembered as absolute values, and then you can subtract. So I put the larger number on top when I'm subtracting from the smaller number, and I'm going to remember that if my initial value and absolute value is negative, that's larger, the answer is also going to be negative. So I wrote that negative symbol right down here. Let's do that and see if we get the same answer. 4 minus 1 is 3. 4 minus 2 is 3. 1 minus 6 can't do, so I'm going to borrow, turn this into a 1. 11 minus 6 is 5. 5.33. I get negative 5.33 from that first part of my problem. Now with that, the next part of the problem says plus 12.72. So you've got a negative and a positive. Again, different subtract. So I set that up again, subtraction problem, again with my absolute values. So these are written in absolute value form to then subtract. 2 and 3 can't do. I'm going to take the 7, turn that into a 6, borrow, turn that into 12. 12 minus 3 is 9. 6 minus 3 is 3. 12 minus 5 is 7.39. Now, in this case, the 5.33 was negative and the 12.72 was positive. The larger of those absolute values would be the positive value, so my answer is going to also be positive. If you look in both of these ways in which I solved this problem, I got the exact same answer. So, one, the old way that we learned it, same sign sum, different subtract, and you follow those rules all the way through. Or in the new way that you learned it in lesson 10, to where you're separating your positive values and your negative values and then putting those two operations together to give you your final answer. In letter C, it asks you to order the numbers from least to greatest. And in your assignment, you're going to practice this using IXL. First thing that I'm going to look at when I'm ordering rational numbers is positive or negative. If it's negative, obviously it's less than. If it's positive, it's going to be greater than. So in this example here, my negative value is -1. If it's least to greatest, that negative value goes first. Now I'm going to have a mix of rational numbers in the form of fractions or decimals. One way to communicate between those or know the difference between those is actually to put those into the same terms. Now if I put 0.85 into a fraction, I have to read this as if I'm reading a decimal without saying 0.85. So the traditional way, this would be 85 hundredths. If I read it 85 hundredths, I can actually write it out as a fraction in that way. This is the tenths and hundredths place. 85 hundredths. Now can I compare those two values as fractions? Well, only if I have a common denominator or something that is similar between those. The other way to do it is to take this fraction and turn it into a decimal. How do you take a fraction and turn it into a decimal? Well, you divide the numerator by the denominator. So you would write this out as 5 divided by 8. Well, you know that 8 doesn't go into 5, so you have to immediately create this decimal value and add a 0. So 8 goes into 50 how many times? 8 times 6. I write the decimal here, I write the decimal here, that's why I say decimal, decimal. 8 times 6 is 48 minus 2. Bring down the next 0. It goes into 20 2 times. 8 times 2 is 16. Subtract is 4. Bring down the 0. 8 goes into 40 5 times. 0.625. Now I know the difference between this value and this value in my decimal form, and I can say which one is smaller, which one is larger. In this case, the least value would be 0.625. Certain fractions you're already going to recognize as the ability to change these to a decimal, like 3/4 is going to be 0.75, 1/2 is 0.5, 1/4 is 0.25. Those things are automatically ingrained in my brain. To know those, if you don't know those, we got to get those down. We got to know our halves, our thirds, our fourths, all as from a fraction to a decimal, that conversion. Otherwise, if you don't know it, then you're going to be using this strategy to divide each time. That's completely fine if you don't have those things memorized, but you're going to get used to finding that same answer each time that you do it using this strategy here. So I got 0.7. 0.85, the smaller of the numbers in terms of that same place value, show you that this is the least, a little bit bigger, and the greatest. Order from least to. Lesson practice problems, letters D and E. In letter D, we're going to get to practice what would be our good strategies for decimal places with those positive and negative values, adding and subtracting real numbers, and also what you're going to do just a slight bit differently when it comes to fractions. And in the last problem, we're going to put that into real-world application with a word problem. Let's take a look at letter D to start with. It asks us to compare. That means you're going to find out which side is greater than, less than, or even if they might be equal to each other. By doing that, you're separating this problem into two separate problems and then comparing at the very end. Let's start with our decimal side. Anytime we have decimals, we need just to simply make sure, addition and subtraction, that those decimals line up with each other. In this case, let's remember that our strategy says separate your positive values from your negative values in the order that you're thinking about adding numbers. Normally, we would say order of operations, well, let's just work left to right, and we would add and subtract these two because this is a negative value. But now we learn the strategy to put the negatives together and the positives together. I'm going to do this part of the problem first because those are both negative values. Same sign sum, I can add those two values up. I would have negative 5.2 and negative 2.8 and add those together. In this case, a negative and a negative. They're going to give me a negative again. I'm adding now because it's the same sign. 2 and 8 is 0, carry the 1. 1 plus 5 is 6, plus 2 is 8. That's going to give me an overall value of -8. Now I have 3.2 that's positive, and this is negative. I have a different subtract situation going on here. Now I'm going to take the absolute value and take 8 minus 3.2. Notice I wrote the decimal, even though 8 could be written as just 8. I wrote 8.0 so that I have those decimals that line up. 0 minus 2 you can't do, so you have to borrow. 8 becomes 7. 0 turns into 10. 10 minus 2 is 8. 7 minus 3 is 4. 4.8. Now because, again, -8 was the larger of the absolute values, this is going to be given a negative value for this left-hand side of the problem. If you look at the right-hand side, now we have fractions. You have to remember, in addition and subtraction, real numbers for fractions, you need to have common denominators. The rule still applies where you can separate positive and negatives and then combine those values at the end. Here you've got 7/12 minus 5/12 plus -11/12. You're probably saying to yourself, well, Mr. Shane, the first one is subtraction and the second one is addition, so you don't have anything that is similar. Well, if you look at minus, subtraction is a way in which this value, this sign, applies to this next number. This is technically a negative number, and -11/12, even though it's added, is a negative number. So I'm going to put these two together first and then come back to 7/12, which is a positive. If nothing is written there, you can think about it as a positive. So here I'm going to add -5 and -11. 5 plus 11 is going to give me 16. I keep them negative, same sign sum, keep the same sign. And now I have positive 7/12 minus 16, or plus -16. It can be thought about as addition or subtract the negative, either way. In this case, I have two different signs, different difference subtract. I would have 16 minus 7 as my absolute values. 16 minus 7 is going to give me 9. Now the larger of those absolute values was -16, so I have -9/12. That can be reduced to -3/4. In letter E, I'll read the problem for you. Letter E says 35. Jonah ran a race in 32.68 seconds. Jared finished 1.2 seconds before Jonah. Gail finished 3.01 seconds after Jonah. How many seconds did it take Gail to run the race? Oh, I apologize. We got to go back to letter D. We didn't compare these two. We had -3/4 and we had -4.8. Which one of those is larger, and which one does the alligator eat? In this case, we're looking at the smaller negative number. The larger negative number is, the smaller it actually is. So the smaller negative number in this case is going to be our larger number. -4.8 is much smaller, or farther to the left on our number line, than -3/4. So it should actually be a lot closer to 0. So our alligator eats this way. Make sense? In letter E, back to the problem that I just read through, you got 3 participants in a race, and it gives us the qualifying time for one of those participants, Jonah, at 32.68 seconds. It said that Jarrett ran it in 1.92 seconds faster, so I actually subtracted that because his time would be less than this. And then for Gail, added 3.01 seconds to the overall time. Now it said, what was Gail's finish time? Mr. Shane took the liberty to take Jonah's time, what we know, and then add the value here. Here now you're just separating the word problem into what you know and what you don't know. Here's what I know and here's what I know. Now it's asking me to find that actual value, or the value of those two things added together. I rewrote that in the problem here. Now we simply add those up. 8 plus 1 is 9. 6 and 0 is 6. 2 and 3 is 5. And 3, 35.69, was the total time for Gail. That's in seconds as our label, and you have all of those problems solved for you. Hope this helps with your assignment. Good luck.